Hi, I wanted to show you our molecular model set. I'm going to demonstrate what you ordinarily would construct during a lab that was in person. So let me show you. These chemistry sets come with these separate balls and these connectors. So what you have to do is put these atoms together by bonding them with the connectors and form molecules. So I'm going to show you how we do that. So this is carbon, this is oxygen, red, and white is hydrogen. So we can form carbohydrates having those three elements. And I'm going to show you some. So the most simple one that I could make for you was water. I could get an oxygen and two hydrogens and make water for you. And we have the connectors showing the bonds. So let me move these out of the way and show you that other than that, I could make something like carbon dioxide. So I have the carbon in the middle and the oxygens. And these are excellent tools because they come with a hole with a number of electrons that has to do with the number of electrons that are free to bond. So when I'm constructing these, I know that if I have used all the holes, I know that I've used all the electrons and I'm all set. I wanted to show you the carbon dioxide because this is an example of a double bond. I need two connectors showing it's a double bond as opposed to the single bond. So again, water and carbon dioxide. Next, I'm going to make a molecule that's bigger, which is what your assignment is. I'm going to make a molecule that has 6 carbons. So there is the skeleton of the 6 carbons, but quite a few holes still to be filled. So I have to fill up with the oxygens and the hydrogens that are going to make part of this glucose molecule that I want to show you. So I've done that. All these connectors here, each one of these carbons is going to have a connector that is going to have attached onto it either a hydroxyl, which is the oxygen and one hydrogen, or just a hydrogen onto each one of these plus one double bond. Okay, so I have done it for you and I'm bringing that one into view. I'm going to move this out of the way and show you that that's, once I fill it in, that's what it would look like. On every carbon, I put a hydrogen and an OH, an oxygen and a hydrogen. A hydrogen, oxygen, hydrogen, attaching onto the core 6 that I first showed you. On top of that, glucose has one double bond. So that's what a molecule of glucose would look like. A whole lot bigger than that carbon dioxide I first showed you, for example. Now, if I were to make fructose, I'm going to show that next to you. It looks very similar. It has 6 carbons. It also has a double bond. It has hydrogens and OHs attached onto the carbons. But the location of the double bond is in a different place. It's on carbon 2. 1, 2, 3, 4, 5, 6. Whereas this is on carbon 1. So monosaccharide. Monosaccharide. Now, we want to join these and form a disaccharide. And we could join another one and form 3, and we could put on another one and form 4, 5, 6, 7, and we could make long chains of molecules, like starches, for example, that are very, very big molecules. So how do these attach is what I want to show you. And vocabulary that you're going to see is this. Dehydration synthesis, and I'm going to flip this, hydrolysis. Dehydration synthesis. First, Synthesis means we're going to synthesize a new molecule. So let's go from having 2 molecules to having 1. So if I turn this around, this is what I'm going to do. I am going to remove a hydrogen from one of the molecules. And I'm going to remove a hydroxyl, an OH, from the other molecule. And they're going to join in that one location. And now I have a disaccharide. And what do I have left over? Water. So if I have water left over, that is an example of dehydration. I removed water. Synthesis. I synthesized a molecule. That's dehydration synthesis. Now you eat this. You cannot digest this. Too big. You have to break it down into monosaccharides, because that is what you can utilize to make ATP. So you have to break it apart with an enzyme. So we will go again, 1, 2, 3, 4, 5, 6, and we will break this apart. And we have to break water apart. And add the OH to one, and add the H to the other. And what I just performed was hydrolysis. What's that mean? Hydro is water, lysis is to break. So I broke the water apart and added those atoms onto the original molecules. And now again, I have 2 monosaccharides. Good.